right, lecture 4.3. Okay, so we're looking at the logarithmic functions, also called just logs for fun or for short. So we're going to consider the exponential function f of x equals base a to the x power. All right, so with this, if a is greater than 0, we have to have that a is greater than 0 and a cannot equal 1, then a logarithmic function with the base a is defined by log base a of x equals y, which when we switch it to exponential form, it's a to the y power equals x. So a to the y power equals x. All right. So for example 1, we're going to graph these two functions, f of x equals 2x and g of x equals log base 2 of x. Okay, so this is an exponential function and this is a logarithmic function. Okay, exponential because we have our variable in the exponent, logarithmic because we got the word log. Okay, so we're going to graph them on the same coordinate system, and let's plot at least 3 points for each graph. All right, so let's see. I'm going to do f of x in purple. All right, well, this one's rather simple, so I'm just raising 2 to some power, so let's try 2 to the negative 1 power. That'd be a half. 2 to the 0 power would give me 1. And 2 to the 1 power would give me 2. Okay, I'm going to go ahead and plot these points. So let's see. Negative 1 half. 0, 1. And 1, 2. Okay, so graphing these in. All right, in question, can we ever raise 2 to a power and get the y value of 0? No, it's never possible. Okay, so we have our asymptote here, horizontal asymptote of y equal to 0. All right, so let's go ahead and graph g of x. All right, so I'm going to pick, now this is kind of strange. I actually want to take a look at g of x in the exponential form. So this is saying 2 to the x power equals y. All right, so what I'm going to do, I'm actually going to pick the x values because it's easier to solve. Okay. Sorry, I switched that in wrong. It should be 2 to the y power equals x. 2 to the y power equals x. Okay, so sorry, I'm going to be choosing the y values because it's easier to solve. Okay, so let's see. Same thing, I'm going to go with negative 1. So 2 to the negative 1 power would give me a half. Let's go with 0. 2 to the 0 power is going to give me 1. And then let's go with 1. 2 to the 1 power will give me 2. All right, so let's plot these points. Half, negative 1. Um, 1, 0. And 2, 1. Okay, you might be noticing something interesting here. These are starting to look like they're the inverses of each other, because notice the x and y values are perfectly switched. Okay, and they look like they are reflecting about the line of symmetry there on it. Okay, which in fact they are. Okay, so logarithmic functions and exponential functions are actually the inverses of each other. Okay, so these two are the reflections of each other about the line y equals x. Okay, so the question is, does g of x have a asymptote? And yes, it does. Has the asymptote here at x equal to 0. Okay, so these guys are inverses. Okay, along this line here, they are inverses. All right, so let's take a look at the domain. So domain for f of x, let's see, negative infinity to positive infinity. How about the range? Well, it can't go down into the negatives. It can't go past 0. So it's going to be 0 to positive infinity. Do we have any x-intercepts? Well, no, because the x-axis is my horizontal asymptote, so none. Do you have any y-intercepts? Well, we do, right there. It's 0, 1. Do we have any horizontal asymptotes for the purple graph? No, we don't have any horizontal asymptotes. Oh, I'm sorry. We do have a horizontal asymptote for the purple graph. It's this one here, y equals 0. Okay. Do we have any vertical asymptotes up here? Nope, no vertical asymptotes, so none. All right, so how about the pink graph, g of x? The domain? Well, we can't have any negative values. So real quick, how do we know that? Well, is it possible to raise 2 to a power and end up with a negative number? No, you cannot ever raise a base to some power and get a negative number. All right, so g of x, we cannot use any negative x values, okay? So no negative x values, so my domain is going to be 0 to infinity. Okay, but my range, I can use negative y values, okay? So I can use the negative y values and I can use the positive y values. So my range is, this time it's negative infinity to positive infinity. So notice the domain and range are switched on these, okay? Makes sense because they're inverses. All right, x-intercepts, do we have any? Yep, 1, 0. Y-intercepts? No, we don't because that's actually along our vertical asymptote, so no, none. Horizontal asymptote? No, we don't have a horizontal asymptote. Vertical asymptote. Yes, we do right here at x equal to 0. All right, so there we go. We have the graphs, the exponential graph and the logarithmic graph, and they are inverses of each other. All right, so here we go. We're going to look at some transformations of logarithms. So, example 2. We're going to sketch the graph of the parent function, f of x equals log base 2 of x, along with the given transformations and fill in the table. So just kind of like how we did for exponents. For exponential equations. All right, so let's see. Okay, starting with our parent function. I'll do it in black. Y equals log base 2 of x. And when I'm filling out my table, because I want to pick some 3 main points I'll be using for the transformations, I'm going to go ahead and switch this into exponential form. So it's 2 to the y equals x. So for this, it's easiest if we pick y values and solve for x. So 2 to the negative 1 power, as we did before, is a half. 2 to the 0 power is going to be 1. And 2 to the 1 power will give me 2. But you know what? Because this graph is so, sorry, I whacked the table there. Because this graph is kind of squished, I'm actually going to pick a farther apart value here. I want to pick 2 to the 2nd power. So 2 to the 2nd power, that'll give me 4. Okay, just because my graph is kind of squishy here. Okay, so 4, 2. 1, 0. And negative half. So a half, negative 1. All right, so there we go, my graph. And I have my vertical asymptote, x equal to 0. All right, so the domain of this function, well, the domain is going to be 0 to infinity. My range is actually going to be negative infinity to positive infinity. Vertical asymptote, well, we said it was x equal to 0. Any y-intercepts? No, because we have that vertical asymptote on y equals 0, so none. How about x-intercepts? Yep, we got that one right there. 1, 0. All right, so let's go ahead and graph the next one. Y equals 2 plus log x. So what transformation is that? Well, that is going to be shifting up 2 units. Okay, so that means I'm going to add 2 to all of my y values. So adding 2 to this y value here is going to be half positive 1. Sorry, half, yeah. So half, why did I put that on the negative 2 there? I do not know why I put it there. That's in the wrong place. It's supposed to be, there we go, half 1. Okay, adding 2 to that is going to give me positive 1. There we go. Oops, I'm supposed to be doing this in pink. Half 1. Adding 2 to 0 is going to be 1, 2. So 1, 2. Adding 2 to 2 is going to be 4. So 4, 4. Okay, our horizontal asymptote is not going to change. Sorry, vertical asymptote, excuse me. It just stays at x equal to 0. Because we've shifted y values and we haven't shifted the x values. So x equals 0 will stay that way. All right, go ahead and fill out the domain range and check back with a second. All right, let's see, domain, same thing. Range, also same thing. Vertical asymptote, still the same thing. Y-intercept, still the same thing. X-intercept, oh, that's actually going to be something else. So I'm going to quickly solve for the x-intercept. So we're using our equation. Let's see, that's going to be, here we go. So 2 to that. It's going to be 1/4 0. Okay, so we could check that. Here, let me pull out sticky note. Let's solve for my x-intercept by setting y to 0. So this is saying 2 to the second power equals x. Well, what is 2 to the second power? It's going to be 4. It's going to be a 4th. Sorry, that's 2 to the negative 2. 2 to the negative 2 power is going to be a 4th. Okay, so I have my form. 4th 0 is my x-intercept. Okay, because we set y to 0 and we solved for x. All right, let's see, next one. Okay, so go ahead, try to see what you think the transformation is going to be for this one, and check back in with me with a second, or in a second. All right, so y equal log base 2 of x plus 2. Okay, this time the 2 is inside the parentheses, so that's going to be shifting on my x values, so that'll be shift left 2 units. Okay, so that means we're going to take 2 away from all of the x values. Okay, so taking 2 away from 1, 2 is going to be negative 1, 2. Taking 2 away from 4 is going to be 2, 4. Okay, taking 2 away from this one, that's going to be negative 1/2, 1. And aha, so now we've actually affected our x values, which means that our vertex, sorry, not a vertex, our asymptote will be shifted over 2 units as well, because that's now affecting my x values. So that's going to be x equals negative 2. Okay, so when you change something to your x values, that's pretty much when your asymptote will be shifting. Okay, so there we go. All right, let's see. Go ahead and fill out your domain range and check in with me in a second. All right, so let's see. Domain. Oh, it's changed. It's negative 2 to positive infinity because our asymptote got moved over. Range, still the same thing here. Vertical asymptote. Ah, that changed. That's x equal negative 2 because we shifted over 2 units. Y-intercept. Ah, we actually have a y-intercept because look, it's crossing. So we're going to go ahead and find the y-intercept. Okay. So for the y-intercept, You're going to set x to 0. Okay, so this is saying 2 to what power gives me 2? Well, that's going to be 2 to the 1 power. Okay. So that has the value of 0, 1 as our y-intercept. Okay, and our x-intercept, I don't know what it is. I'm going to have to solve for that one too. Okay, solving for the x-intercept. Let's see, so starting with y equals log base 2 of x plus 2. All right, plugging in 0 for y. This is saying 2 to the 0 power equals x plus 2. Well, 2 to the 0 power is 1. So that's going to be x plus 2. So subtracting 2 from both sides, I have negative 1 equals x. All right, so my x-intercept is negative 1, 0. Oh, just realized I graphed this one wrong. I was looking at that one. I was not looking at my parent function. Very, very bad. Sorry about that mistake. Hopefully you were not using pen as I am, but if you were, I'm very sorry. Okay, sorry, we're supposed to be looking at our parent function. I don't know what I was doing there. Okay, so we are supposed to be subtracting 2 from these values. So for 2, that's going to be 2, 2. Aha, that's why it looked suspicious. Okay, subtracting 2 from that, that's going to be negative 1, 0. Which would have made it way easier to find my x-intercept there. And then that is going to be negative 1.5. What is that? Whoa. This is the half minus 2. This is going to be 2, 4. So it's going to be negative 3 over 2. Yeah, negative 1.5. All right. Negative 1.5, comma, negative 1. Whew, there's a bajillion little dots there. All right. A struggle with this blue one today. Okay. All right, sorry about that. That graph was incorrect. So we're looking at the parent function and not the pink function. All right. Next one. Let's go ahead and do this in green. All right, go ahead and try. Actually, you know what? I'm going to do this. Oh, I didn't bring my orange. Shucks. I'll do this in purple. All right, go ahead and try graph that one and check in with me in a second. All right, well, this is y equals negative log base 2 of x. So this is a reflection about the x-axis. All right, so reflecting about the x-axis, that means you're going to multiply all the y values by negative 1. So this will end up being, all the y values by negative 1, so that's going to be 4, negative 2. And that's going to be, oh, well, that doesn't change, 1, 0. And this will be half positive 1. Okay, nothing happens to our asymptote. It's still going to be at x equals 0, and there we go. So, what is the domain? 0 to infinity, range, all real numbers. Vertical asymptote stays the same, we didn't change it. Y-intercept, nope, because we still have that vertical asymptote there. And then our x-intercept, that one did not change, 1, 0. Right there. Okay, last one for these transformations. I'm going to do this one in green. Okay, so the negative inside the parentheses means we're going to reflect about the y-axis. Okay, so reflecting about the y-axis, that means we're going to be multiplying all of our x values by negative 1. Okay, so that's going to be negative 4, 2. This will be negative 1, 0. And this one will be negative half, negative 1. All right, drawing that in. Still hasn't changed our asymptote of x equals 0. All right, so that means that my domain will be, my domain switched. Look, we're using the negatives now. That's going to be negative infinity to 0. Then the range, still the same. Vertical asymptote, nope, we didn't change that. Y-intercept, still none. But our X-intercept did change. It's negative 1, 0. All right, so there we go with all the transformations. Whew, that was a lot. All right, lots of little numbers, lots of negatives and fractions flying around. All right. Okay, so we're going to take a look at, so the base of your logarithmic function can be technically any number, but there are two main bases that we use, okay, because they appear in sort of natural life applications, so they're the two that we've given names to, actually. Okay, so normally you would just have log, and then you would indicate which base you're using, 3, or maybe if you're using 4, you indicate which base. But there's a log that appears very often in applications, and that's log base 10. It appears so often, we decided to call it the common log, okay? So the common log has base 10. So just like when we're normally taking the square root of something, we don't actually put in that 2. Just because we use the square root so often, people have said, you know what? If you don't see a number up there, you're allowed to assume it's 2. Same thing goes for logs. If you do not see a number under the g, you're allowed to assume it's a 10. Okay? But there's another common base that appears in life, which we have talked about, which is e. Okay, 2.72. Well, log was taken, just the log, so we couldn't use that option. So they decided to call it the natural log of, which is just ln. Okay, so if you see ln, this is a fancy or a shortcut way of writing log base e. Okay, so these are the two logs that we see most of the time. Log, if you just see a log, you're allowed to assume the base is 10. If you see ln, the base is e. Okay, and these two, common log and natural log, are the ones that appear on most calculators. Okay, so most calculators will only compute or graph base 10 and base e. Okay. So here we go. We have the function f of x equals 1 minus natural log of negative x. So first we're going to graph the parent function, and then we will graph the transformation. So what is the parent function? Well, the parent function is y equals natural log of x. Okay, so graphing this, x and y, I'm going to transform this first into the exponential form, so that's going to be e to the y power equals x. Okay, and remember e is about 2.72. It's easiest if I pick y values.